In this video, we're going to review how to solve an equation with a model as well as algebraically. In this video, we're going to work through 3 example problems, and in the second video, we'll work through 2. I will also show how to do a verify for 2 of the equations. So number 1 says solve the equation x plus 2 equals 4. We'll start by solving it with our model or algebra tiles. So on the left side of the equation, we're going to draw one x tile that's positive or unshaded and 2 unit tiles. On the right side of the equation, we're going to draw 4 positive unit tiles. We'll draw a line to represent our next step. In the next line of work, our goal is to isolate x, or the x tile, or solve for x. So we're going to use the additive inverse, or the opposite, to get rid of the unit tiles on the left side of the equation. So the additive inverse of positive 2, or the opposite, is negative 2. And whatever we do to one side of the equation, we have to do to the other side of the equation. So we'll be adding negative 2, or 2 shaded unit tiles, or 2 negative unit tiles, to the right side of the equation as well. So on the left side of the equation, the unit tiles will cancel, and we'll be left with our x tile, which is what we're trying to solve for or get alone. On the right side, we'll also cancel our 0 pairs, and we'll be left with 2 positive unit tiles. So that means x equals positive 2. We're going to solve it algebraically. We're going to write down the equation. And the algebraic way should come out with the same answer as the tile way, and the steps should be similar. So meaning in my second line of work, I'm going to use the additive inverse of 2, or the opposite of 2, which is negative 2. So I'm going to add negative 2 to both sides of the equation. That's also what I did when I solved it with the algebra tiles. Positive 2 plus negative 2 is 0, so I'm going to be left with x. Plus 0 is x, so just x is all alone on the left side of the equation. And the right side of the equation, 4 plus negative 2 is 2. Second example we're going to work through is we're going to solve the equation x minus 2 equals 4. Again, we'll start with drawing out our algebra tiles. When we're solving this one algebraically, we should think about how we're going to solve this algebraically. When we're solving this algebraically, our first step should be to change subtraction to addition. So we're going to change this equation into x plus negative 2 equals 4. That's going to help me now build my tile, because it's 1 positive x tile and 2 negative unit tiles on the left side of the equation. On the right side of the equation, I'm going to have 4 positive unit tiles. So this problem is similar to the previous one, but obviously there are some distinct differences. That's my first step. Second step, I'm going to redraw what I had in the first step. And I'm going to use the additive inverse because this problem or this equation deals with subtraction or addition, which means I need to use the additive inverse. So I'm going to add to both sides of the equation the additive inverse of negative 2, or the opposite of negative 2, which is positive 2. When I simplify or look for zero pairs that cancel, on the left side of the equation, I'm going to be left with just one x tile, because I have zero pairs, which means all of my unit tiles go away on the left side of the equation. And on the right side of the equation, there are no zero pairs, so I'm left with 6 positive unit tiles. And now we'll go over to the algebraic way, and we'll finish solving it, and we should get the same answer we got with our tile way. So we're going to use the additive inverse of negative 2, or the opposite, which is positive 2. So we're going to add positive 2 to both sides of the equation. The negative 2 plus the positive 2 is 0, and the x plus 0 is x, so x is all alone. And the right side of the equation is 6. So my answer is 6. Let's do a check for this one. So in order to do a check, we're going to take what x is, and we're going to plug it in for x in the original equation. So the starting equation was x minus 2 equals 4. So we're going to plug 6 in. We'll be left with 6 minus 2 equals 4. And I'm simplifying both sides of the equation. 6 minus 2 is 4. The right side of the equation was already simplified, and so it checks out. 4 equals 4. 4 is not my answer. The answer to the equation was still 6, but this tells me, since I got a true statement, that my answer was correct. The last one we'll do in this video is we're going to solve an equation involving multiplication or division. So the third example, we're going to solve 2x equals 4. So we'll start by drawing out 2 x tiles on the left side of the equation, and on the right side we're going to have 4 unit tiles. We'll redraw the equation. And I'm redrawing and kind of reorganizing my equation because I'm looking to make an equal number of groups on each side of the equation. So since the left side of the equation has 2 x tiles, I'm going to make 2 groups on the left side of the equation, and each one's going to have an x in it. On the right side of the equation, I'm going to make 2 groups, and each group has 2 unit tiles. That's my second step. And from that, I'm able to say that if 2 x tiles equals 4 unit tiles, then 1 x tile is equal to 2 unit tiles. So x equals 2. We'll solve this one algebraically. We have 2x equals 4. When we're solving this and we're doing our groups, we are no longer using the additive inverse, we're using the multiplicative inverse, or the reciprocal. So our equation was 2x equals 4. We want to get x alone or isolated. We're looking at the coefficient of x, and we're going to take the reciprocal of 2, which is 1/2. And we're going to multiply both sides by 1/2. 1/2 times 2 is 1. 1x, or x, equals, and 4 times a half, or 1/2 of 4, is 2. So we end up getting the same answer. In the next video, I will work through 2 more examples, and I'll also show how to verify in an equation that involves multiplication.